So again, good morning to all. In this video, we are going to discuss the concept of linked list and array implementation of linked list as well as implementation of linked list with the help of structure. So let me explain everything one by one. So what is linked list? In fact, a linked list is a collection of nodes. So we have seen in the last video, a linked list is a collection of nodes. Okay. In the second line, we have seen that a node contains two parts. The first one is data and second one is address of next node. So what is the meaning of this one is, let me explain in detail. When we talk about the array, what is the meaning of array? The meaning of array is, I have a memory has been divided into equal side blocks. Okay, so that is the concept of array. A memory has been divided into equal side block. So there is no need to keep track information regarding blocks. Why it is not necessary? Because if you have a base address, you can calculate the address of any block. Okay, so we have seen that in a case of array, there is no need to store the information about blocks. If you have base address and we have a word size, you can calculate address of any block. That is the case with array. But we have seen several times, we have couple of disadvantages of this approach. What is the disadvantage? Whenever any block has been deleted, so what you have to do, you have to shift the element. Okay, or whenever you have to insert a new block to a particular position, what is going to happen? You have to shift the block to the right. Why? Because you have to maintain the properties of array, and properties of array says that all blocks should have equal size of, all blocks should have equal size. Okay, so that is a case of array. But what I can do, I can modify array in such a manner that I can solve this problem. Let me explain to you what can I do in a case of array. Let's say it is an array. It is an array A and I have couple of blocks. Okay, then what I have done, I have stored the first element. So what I will do, I will store the first element. Then I have stored the second element. Let's say it's 25. Then let's say I have stored the third element. Let's say 34. Let's say I have saved one more element. Let's say 45. Now what is the task? The task is, let's say I want to delete the element number 3. So which one is that? Is 34. Okay. If the array index starts from 1, which one is element number 3? That is 34. So what I can do, in order to delete 34, what I have to do in a normal case, I have to shift 45 to here. But rather than shifting, what can I do? I can take a special memory, and in this special memory, what can I do? I can keep track around 3. It means I can save 3, and this memory indicates that third block is not in array. Are you following this? That is not a good approach, but that can be the one approach. Rather than shifting, I can store this location. So what is the benefit of this? Whenever I am going to traverse the array, at the same time, I will traverse this memory also. It will indicate that third block has been deleted. It means after 2, I have to visit the fourth one. Are you following this? After 2, I have to visit the fourth one. So that is the case. It means with array I can add special storage. Okay, that is the concept of array. With array I can add the special storage. So the benefit of this one is I can delete element and I can maintain the property of array also, and there is no need to shifting. You might be think that, oh sir, but what is happening? Array property is violating. So generally it is not happening. Why it is not happening? Because the size of a block is consistent. I'm just saying that you have to skip block number 3 because it has been deleted. Later and you can save new variables to you. But what you have to do, you have to look at the block number 4. Okay. So that is the case of array. Okay. So what we have seen there, we have seen that if I will put a special storage along with array, in a case of deletion, I can delete the element without performing shifting. Okay, so what programmers have done, programmers have like followed the same approach and implemented a new list that is called linked list. So let me explain the implementation of linked list with the help of array. Okay, at the first instance it seems very difficult, but I advise you, please spend couple of time so you will get an idea. Okay, so please give me some minute. So let's say I have an array like this. So let's say the size of array is, let's say 1, 2, 3, 4, 5, 6, 7. So the name of the array is data. Let's see. And the size of this one is 1, 2, 3, 4, 5, 6, and 7. Okay. So along with this array, I have taken one more array. Okay. So I have taken one more array, and the size of this array is equal to this array. It means the size is quite equal. So like this. So in general, they are called parallel arrays. Okay, they are called parallel arrays. Let's say the name of the array is next. So what we have done, we have taken two arrays. The first one is data and second one is next. Along with these two arrays, I have taken two variables like this. Away and start. So what is the meaning of this one is, I will explain away later, but first of all, let me explain start. Start contains the value where the array has been started. It means start contains the value where I will start to save the element. So in array, what generally happens, we start saving element at element number 0. So I will put 0. So that is the initial condition. Data is the array in which I want to put couple of element. Next will indicate where the next block needs to be like stored, and start stores the address, or we can say index of first element. Okay, let me put 1 because I'm using algorithm. Okay, so let's say I want to insert 10. So what I will do, I will put 10. But whenever I will put 10, I will put 2 also. So I am indicating that first block has been achieved at block number 1, and after that next block is block number 2. So you might be thinking that, so what is the benefit of this approach? If we are dealing with array, it is very obvious that if the first block is block number 1, the second will be block number 2. But let me explain. Okay, then let's say next element is 15. So I have instructed to the compiler that second element will be 15 and the next block can be found at block number 3. Okay. Let me save a couple of more elements like this. So if we look closely, what is the meaning of this one is, the meaning of this one is I'm instructing to the compiler that please start at block number 1, that is the first block, and after executing block number 1 you have to, if you want to access the block number 2, you can look here. Okay, but just pay attention, that is quite important. Let's say someone says that please delete block number 3. Are you following that? So someone says that please delete block number 3, it means 24. Okay, let's say I have couple more elements like this. Okay, and someone says that please delete block number 3, it means 24. So someone is requesting me from me that please delete 24. So in a case of normal array, what I have to do, 89 will come here, 72 will come here, and 36 will come here. It means it contains lot of shifting. But I am following this approach, and what is the benefit of this approach is, the moment I will delete 24, I am not going to perform shifting. Okay, what I will do, I will follow the nature of this policy, and what I will do, I will check first block is block number 1. Please pay attention. The first block is block number 1. After that, next block can be found at block number 2, that is 15. The third block can be found at block number 3, that is 24. It means after block number 2, what was the third block at the block number 3? But after third block, which one is the next block? That is block number 4. It means we have a block number 2, block number 3, and block number 4 till now. But what will happen if I will delete block number 3? Which one will be the next block after 2? That is block number 4. So what can I do? I can indicate to the programmer that after block number 2, there is no block number 3, because we have deleted the element of block number 3. And which one is the next block? The next block is block number 4. So I can put here block number 4. Are you following this? And let me rough here like this. So what is the meaning of this one is, by changing the value of a pointer, or we can say a location, I am going to delete the element. So if someone looks at, there is a block number 1, that is 10. Then after block number 2, then that is 15. Then after block number 2, we don't have block number 3. We directly have block number 4. So we directly come here. So by following this approach, what I am going to do, I am going to delete the element, okay, and I am not going to shift the elements. Are you following this one? So we have deleted 24, and we are not going to shift the element. Okay. Then let's say I will explain in detail, but for the sake of simplicity, let me delete block number 1. So someone says that please delete 10. Please delete 10. So till now what is happening? My list has been started from block number 1, that is 1. It means the first block can be found at the first position, and the value is 10. If someone says that please delete it, so what I will do, I will check that after block number 1, where is block number 2? At position number 2. Are you following this? At position number 2. So the moment, the current scenario is block number 1 and block number 2. Okay. If I will delete block number 1, what will happen? Block number 2 will becomes the first block. Are you following this? If I will delete block number 1, block number 2 will become the first block. So what is the meaning of this one is, I will instruct compiler that I have deleted 10, and after 10, block number 2 was the next block. But when I will delete 10, so block number 2 becomes the first block. It means I will put here 2. So it will indicate to the compiler block number 1 is not a first block now. Block number 2 is a first block. Are you following this? Block number 2 is a first block. It means after changing this value, I can change the starting position of data, or we can say starting position of array. So in normal case, what happens, if you want to traverse array, you have to apply loop from 1 to n. Are you following this? But in a case of linked list, what you have to do, you have to start with start. It means the variable start will contains the address, or we can say index of first block, okay, where it has been located, and then the next block can be found at the next part, okay. So by putting extra storage, what I am going to do, I am indicating to the compiler where the next block can be found, okay, whether this one or this one, okay. So that is like I have given you the idea about a linked list. So in a similar manner, we can insert the element as well as we can delete the element. Are you following this? So let me explain to you again. What is the benefit of linked list? In linked list, what is happening, I am not going to following the properties of array as that is, but along with this, I am like allocating extra space. In that space, I am saving information about the next block. Are you following this? About the next block. So whenever I am going to delete the element, I am not going to change the state of all elements. I am just going to change the storage of next block, okay. So let me explain the algorithm of insertion inside the linked list. So that is extremely important, so I will request you to focus on this one, okay. Just a minute. So what is the task? The task is to explain the concept of linked list. So first of all, let me explain from the very initial point, okay. So whenever we are going to delete an element, what is happening? A block has been free, okay, because we have deleted the element. So I want to keep track about the deleted blocks. So let me explain to you what I am going to do. Let's say I have an array named as data like this. And I have a array named as next or link. So in your book, it is given as the name of this one is link. So I am taking as link. Okay. And again, so at the very starting point, we don't have any data inside the linked list. Are you following this? So the value of start becomes 0 because we don't have any data. That is dummy value. And we have a special pointer named as avail. So let me explain what is the like importance of avail. Avail contains a list. Let me write down here. Avail contain a list of free blocks. So similar to start contains a list of data. Avail contains the list of free blocks. So till now it is pointed to do one. So let me explain first. So what is the meaning of this one is? The meaning of this one is not like that. Oh, sorry for this. Let me rub this one. Yeah, like this. 2, 3, 4, 5, 6, 7, 8, and none. So what is the meaning of this one is? It is saying that block number 1 is empty. After block number 1, block number 2 is empty. After block number 2, block number 3 is empty, and so on. So it contains the list of empty blocks. Okay. Now let me write down the algorithm. So please pay attention, that is quite important. So I will explain one by one. So name of the algorithm is insert. Following this, the name of the algorithm is insert. What is the parameter? Data is a array. Second is link is a array. An item we have to insert. Okay. And then we have to insert LOC. Are you following this? So we have taken a data that is currently empty. It means I want to insert some element to this. Link is a array in which I will store the information of next block. Item, the item we want to insert, and that is LOC. Here the location of the item you have to insert. Okay. So let me start from here. 1, 2, 3, 4, 5, 6, 7. Okay. Let's say you want to insert 30 as a first block. So let me write down here like this one. Block number 1, 2. So my task to insert 10, 20, 35, then 45, and then to delete 20. Okay, so let me explain one by one. First one is I want to insert 10. So as a user, I don't bother whether you use array or linked list. I will not think about this one. As a programmer, you have to think. Okay, so as a user, you are interested in order to store these 4 elements. Okay, so if someone says that please store 10, so what is the meaning of this one is? The meaning of this one is users are interested to save 10. Are you following this? User are interested to save 10. So what I will do? First of all, I will check whether the space is available or not. Okay, by looking the avail pointer. It means if all element has been filled inside the array, I will say that there is no space. It means if avail equals null, I will print no space and exit. So what is the meaning of this one is, please pay attention. The meaning of this one is you want to insert a element inside the array, but space is not available. Okay, the moment space will be available, the element will be inserted. Okay, so before writing any algorithm, every time you have to check whether the space is available or not. Okay, if the space is available, so you have to take control of that space. So what I have to do, please pay attention. You will contact to avail. So right now avail is 1. It means this condition become false. So I will come at point number 3. Are you following this? Because avail at the first position. So what is the meaning of this one is, this variable says that position number 1 is free and you can use that. Are you following one? Position number 1 is free and you can use that. But the moment position number 1 will occupy, what will be the next free location? So you can see that if position number 1 is occupied, the next free location will be 2. Are you following this? The next free location will be 2. So what you have to do, you have to take a pointer, and will control the block number 1. So what you have to do, let's say I have taken a pointer new, and we have copied the value of avail. So what is the meaning of this one is, that is new is a temporary variable, that is new, and I have copied the value of avail 1. It means new also pointing to this position. So what is the meaning of this one is, the meaning of this one is I will take control of this block and I will use that. Are you following this? I will use that. Okay. So the role of avail becomes over for this particular value. But when the next time I want to insert the element, block number 1 will not be available. Are you following this? Block number 1 will not be available. So what I have to do, I have to update avail. So which one is the next free block? The next free block can be found at the block number 2. Are you following this? And what is the block number 2? Block number 2 is a link part, that is parallel arrays, is a link part of avail. So what I can write? I can write avail equals link of avail. Please pay attention. So you have to focus on two things: how blocks are connected. Are you following this one? How blocks are connected. So if you look closely, what is going to happen? I am indicating to the compiler that I will take control of the first available block, that is block number 1. But after block number 1, which one is the free block? That is block number 2. So next time, whenever you are going to insert the element, block number 1 will be occupied. So you have to update the value of avail, that is 2. It means after inserting 1, the next free block will be block number 2. Okay. So let me copy the element. Let's say the element was 10. So let me copy the element. The name of the array is data. What is the index? That is new. So let me copy the item. Okay. Let me copy the item. Okay. So data name equals to item. So what is going to happen? I have put 10 here. Okay. Then come to the link part. So in the link part, I will put null. So let's say link part of new equals null. So what is the meaning of this one is? The meaning of this one is, till now we have only one block, that is this one, like 10, and after that we don't have any block. Okay, are you following this? After that we don't have any block. It means till now we just have a single block, that is block number 10. And we have stored that. Are you following this? We have stored that. But one thing is remaining, that is start. So you have to instruct compiler that the series is going to be started block number 1. Are you following this? So what you have to do? You have to copy the value of new into start. So what is the meaning of this one is, the value of new is 1, the value of start is 1. So what is the meaning of this one is, it is indicating that block number 1 is the first block. Okay, block number 1 is the first block. So every time when you deal with linked list, you have to take care about the start and the avail. Avail will says that where we will find the free block, and start will say that from where I am going to start the list. Okay, so at the very first instance it looks difficult, but please pay attention, probably you will get the output. Okay, so the next block is 20. So this time I am going to like insert 20. So we have to put a if condition, if loc equals 1, because it will happen in a case of first block only. Okay, so let me explain first, then I will like modify this algorithm. So this time what is going to happen, I am going to insert 20. So what is the meaning of 20? The meaning of 20 is I want to insert a block or data inside the linked list. The value is 20. So what I have to do, first of all I have to check how many elements are in a linked list. So I have to start with start. Are you following this? So start says that I don't know about the number of block, but I can ensure you that first block can be found at location number 1. That is 1. So what is going to happen? I will contact to this one and I will find the first block, that is 10. Okay. It might be possible there are a couple more blocks inside the linked list. So to achieve the address of second block, what I have to do, I have to look at the link part, this one. But the moment I will find that, oh, this address is null, so it is indicating that the next block is like list contains only single block, next block is null, I think. Okay, so we have only one block till now. So the moment I will get null, it indicates end of list. So it ensured me that till now there are only one block inside the linked list. Okay, so again Let me start the algorithm. If avail equals null, what is the meaning of this one is we don't have a space, but avail is not null, it is like 2, so it means we have a space. So what we have to do, we have to copy the value of avail into new. So this time new is indicating the pointer number 2 like this. So let me run this one like this here. And it is saying that the first free block was at block number 2, but the moment block number 2 will be occupied, where will the next free block? The next free block can be found at block number 3. So I have to put here 3. So I have executed this line as well as this line. Are you following this? So I have executed these two lines. Then I will copy 20 here. Okay, that is this one. Then link of new equals to null, so it becomes null. Are you following this? It becomes null. But please pay attention, before inserting 20, who was the first block? Block number 10. What was the last block? Block number 10 was the last block too, because we have a null. Are you following this? But this time what is happening, the moment I have inserted 20, 20 becomes the last block. Are you following this? So what I have to do, I have to put the address of 20 in a link part so that I can connect these two blocks. Are you following this one? So the definition of linked list is, whenever you will list the block number 1, at the block number 1 in the address part, you will get address of block number 2. It means in order to insert 20, you have to modify the address part or link part of block number 1. Are you following this? Block number 1. So in order to insert element and position number n, you have to modify the n minus 1 block. Okay, n minus 1 block. And as I have explained earlier, in linked list, we can't directly say that block number 3 can be found and block number 3. So in order to reach here, I have to apply the loop. So I will explain it later, but somehow I know that this is the previous block. So what I will do, I will modify the value of null and I will put 2 here. So what is the meaning of this one is, the meaning of this one is, your linked list start from location number 1 and the first value is 10. After that, second value can be found at 2 and the value is 20. And after that, null. It means you have inserted 2 elements. Okay. Then let me insert 35. So we have to write something in the else part. Okay. So in next else part we can write calculate the address of previous block. And what we have to do, the moment I will calculate the address of previous block, I have to update the link part of this one. So link of pre equals to new. So what is the value of new? The value of new was 2. It means I will put here 2. Are you following this? That is quite easy. That is 35. So next block is 35. So till now, the first empty block can be found at position number 3. Okay, this one. But the moment position number 3 becomes BC, that position number 4 is the next free block. So I will write here 4. Okay, and I will put here 35 like this. Are you following this one? So I have executed this one and this one and this one. Okay, and I will put here null. But this time what I have to do, I have to modify this one. Okay, so in the else but I will come, I will have to calculate the address of previous block and I will come put here 3. So what is the meaning of this one is, the block number 1 is a starting point, that is 10. After that we have next block at block number 2, then we have next block and block number 3, and then we have null. Okay, let me write 45 in a similar manner. I can write 45. So I will update this one, it becomes 5. Next available block, and here we have null and we have Okay, so what is the meaning of this one is we have inserted 10, 20, 35 and 45. Okay, but what is the benefit of this approach? Let me explain to you. The best thing we have to think about this one. The best thing is that let's say someone says that insert 20 but at the second position, 29, let's say. So someone want to make a list like the first block is, let me write here, the first block is till now, first block is 10, then 20, then 35 and then 45. Someone says that please insert 29 here. So in a case of array, what is going to be happen? In a case of normal array, I have to shift the element. Are you following this? I have to shift the element. Okay. But let me explain to you how we can do this in a case of linked list. If someone says that please we have to insert the element, first of all we have to check that whether the space is available or not. So we have to check avail pointer, that is point number 5, that is not null. It means block number 5 is free. So what I can do, I can take a control of block number 5, the value of new becomes 5 and I can make it 6. It means after 5 the available block is 6, this one. Okay, then copy the data. So what is the data? Data is 29. So let me copy the data. Data is 29. So I have copied the data, this one. After that, what you have to do, you have to put null in a link part. So let me put null in a link part. So I have put null in a link part. That means just a minute. There, let me put null in a link part. So I have executed it here. Okay. But what we have to do, that is a normal case. It means here I am saying that I am putting at the last. Let me explain to you. In normal case, what is going to happen? I am going to put element at the last. That's why in a link part, I am going to insert the data. So we are going to put null. But in this case, what is going to be happen? This is not a last block. Are you following this? This is not the last block. It means in order to insert at the second position, what was the second node? 20, but now it becomes the third node. It means before inserting 29, what is the scenario? Scenario was the first block at block number 10, then at the position number 2, you will find the second block. Are you following this? At block number 2, you will find the second block. But till now, what is going to happen? If you will insert 29, so 29 becomes the second block. It means block number 2 will not be find at the second position. It will find the fifth position. So I have to update this. Are you following this? I have to update this. The meaning of this one is the series start from block number 1, that is 10. That is 10. After 10, the next block can be find at the block number 5. Okay, block number 5. So I will come here. Then in the link part, I will not put null. So we have to update something. So I will give you the complete algorithm, but I am giving you the idea. I have to update something. Now I have to put here the address of the third block. Okay. So which one is the third block? Block number 20. In the last case, that was the second block. So I have to copy the content, previous content of this one here. It means I will put here. So what is the meaning of this one is? The meaning of this one is the series start from block number 1, that is 10. After that, next block can be find at block number 5, that is here. After that, the next block can be found at block number 2, that is here. And then block number 3, that's here. And block number 4, that is here. Then we have to find null here, like this. Okay. So we have to update the algorithm in fact. Okay. So by explaining this one, my motive is to show you that in linked list, by changing some pointers, what I am going to do, I am going to insert the element as well as I am going to delete the element. Okay. So the main benefit is we doesn't need to perform shifting in order to shift the element, in order to delete the element. But the disadvantage is you have to maintain a separate memory. You have to maintain a separate memory for calculating the next block. where the next block has been executed. Okay, so that is the array implementation of linked list. Okay, and every time you have to take care about two variables. The first one is start and second one is await. Okay, if you have any problem, you can come to me anytime. Okay, in the next video we will see structure implementation, sorry, linked list implementation with the help of structure. Okay, thank you.